Okay, so this is on balancing chemical equations and how to do that. All right, so I'm going to try to pull up a highlighter. Okay, or actually no, I like the laser pointer. Okay. All right, so chemical reactions are a chemical change in which one or more substances are converted into new substances. All right, so when a chemical reaction takes place, you always end up with a new substance. And that's how you know a chemical reaction actually took place. It wasn't just a physical change. Okay, so with chemical reactions, you have your reactants, and those are your chemicals that are going to react together. And then you have your products, and those are the new substances that are produced during a chemical reaction. Right, so we write chemical reactions. We can write them out. We use chemical equations. Okay, so on the left-hand side are always our reactants. So in this case, it's carbon dioxide plus water. And then the arrow tells you the direction of the reaction. So that this is saying that the carbon dioxide plus water react to form, and these are the products. You've got glucose, C6H12O6, and oxygen. Okay. All right, so during chemical reactions, matter cannot be created or destroyed. It's only transformed. Okay, so this is called the law of conservation of mass, right? And this can be illustrated by this diagram here. So here we see a candle burning, right, or before it's burning, right? If we were to capture all the gases that are given off when the candle is burning, to capture all that carbon dioxide, the mass for all of it would be the same as when you first had just the candle before it ever burned. What's going on here is that the elements, it's easier to see when you're looking at a chemical equation. But so let me go to the next one. Okay, so here we can see that on our reactant side, we have only one carbon atom. We have two hydrogen atoms over here, and we have three oxygen atoms, two here and one here. Okay, so that's our reactants. On our product side, we have 6 carbon atoms, 12 hydrogen atoms, and then 8 oxygen atoms. Okay, so you can see that if we just went by, if this was the true chemical reaction, that would mean that 5 carbon atoms were being created. Where did they come from? And here 6, or 10 hydrogen atoms were just being created during this chemical reaction. And this would be saying that 5 oxygen atoms are being created during this reaction. And that just doesn't happen. This reaction cannot take place. It would never take place because you don't have enough carbon atoms in the reaction side to equal what's there on the product side, along with the other hydrogen and oxygen atoms. That's what the law of conservation says, that however, we're not going to be creating atoms. Instead, they're only going to be rearranged. So their substances are going to be transformed. If you look, this carbon dioxide and water molecules are going to be transformed into glucose and oxygen molecules. But the atoms themselves are not being created or destroyed. They're only going to be rearranged, right? Which brings us to what this topic is about, balancing reactions. In order to know, so if you're in a lab and you have some carbon dioxide and you have some water and you want to make glucose and oxygen, you need to know how much carbon dioxide to add to a certain amount of water molecules in order to produce glucose and oxygen. Right, so that's what a balanced reaction does. It tells you how much you need to add of any substances, any reactants, to get the desired products, the products that you want. Right, so here this is balanced. If we look, here are 6 carbon atoms, 12 hydrogen atoms, 12 hydrogen atoms on the product side, 18 oxygen atoms on the reactant side, and 18 oxygens on the product side. Okay. So that's the concept of why we have to have balanced equations in chemistry. All right, the act of balancing equations, I find it like doing a puzzle. I kind of like I like to do puzzles, so I kind of enjoy doing it. But some students find it, they don't. Well, some students don't like to do anything, but some students find it not so much fun, I guess. All right, so let's go on from here. Okay, so to balance equations, what we do is we use numbers called coefficients. All right, so we've talked about subscripts before. Remember, subscripts are the numbers that go below, and they only apply to the element in front of it. So this 2 is saying there are 2 oxygen atoms. There's no subscript here, but we can assume there's a 1, right? And here there's a subscript here saying there's 2 hydrogens. All right, and we talked about superscripts where there were charges, like say if this was +1. It was the oxidation numbers, which we've covered before. All right, so coefficients are the numbers that they're written full size. They're not, lower or higher. They're written the same level as the elements, and they apply, how that 2 only apply to the oxygen. Coefficients apply to all the elements after it for that compound. The 6 doesn't apply to here, but it does apply to both the carbon and the oxygen, actually to 2 oxygen molecules. Okay, so what this is, if you put the 6 here, what this is saying is that there are 6 carbon atoms, and there are 6 times 2 or 12 oxygen atoms in this molecule here of 6 CO2. You're saying there's 6 CO2 molecules. All right, that's what a coefficient is, and that's what we use to balance equations. Okay, so when you're balancing equations, just keep in mind you can always change these coefficients, but you cannot change that subscript. That subscript has to stay the way that it is. So we're talking about molecules. Okay, so and that 2 tells you this is carbon dioxide, and they're chemically bonded together. Excuse me. Okay, so what this 6 again is saying is you have 6 carbon dioxide molecules. All right. Okay. When we add a coefficient, we're not changing the ratio, of within a molecule itself. There is still a 2-to-1 ratio between the oxygen and the carbon. Although now there's 6 carbons and 12 oxygens when that 6 is up there. But that's still a 1-to-2 ratio for 12 divided by 6 is still 2. So it's 1-to-2. All right, so there are 5 basic steps to balance any chemical equation. First, you want to list the elements in alphabetical order. Second, write down the number of atoms per element. Third, find a common numerator and write it into the reaction as a coefficient. Sorry, these numbers are wrong. Okay, 4, change the number for all the elements that are affected. And 5, do the same for the remaining elements. Okay, we're going to take this step by step, and I think you'll find this pretty simple to do if you follow these steps that I'm recommending you do. Okay, so this is a chemical reaction for burning propane. So when we burn propane, C3H8, it requires oxygen to burn it. And the products that are produced are water, H2O, and carbon dioxide. All right, we're going to balance this equation. So how much propane do we need in order for this reaction to take place? Okay. All right, so the first thing that we're going to ever do is we're going to list the elements for the reactants and the products in alphabetical order. Okay, so we do this just to add an order to it, just in alphabetical order. Okay, now one thing to keep in mind, you don't have an example here, but every chemical, every element's chemical symbol begins with a capital letter. So they're all of them are just one. But like if it was, let's say magnesium, it'd be M, and then the G would be a lowercase. We'll go to that in the next example to show you that. But anyway, okay, so the first thing you're going to do is list the elements in alphabetical order. So C comes before H, and that comes before O. Both of them come before O. So we're going to list it on the reactant side, and we're going to list it on the product side. Okay, then we're going to write down the number of carbon atoms on the reactant side and carbon atoms on the product side. And we're going to do that for each of the elements. Okay, so here there are 3 carbon atoms on the reactant side and there's only one carbon atom on the product side. Okay, so on the reactant side here, there's 8 hydrogen, and there's only 2 hydrogen on the product side. So on the reactant side here, there's only 2 oxygen, but over here, there's 2 here, plus this one, so there's 3. Okay? All right, so the third step, we're going to find common numerators. So we need these to be equal. All right, so if we start off with, we have 3 on this side, we're obviously going to need 3 carbons on this side. All right, and so what would be a common numerator? Would be to multiply this side by 3, that side by 1, right? Okay, so how we do this, we're going to put a 3, right? We're going to put a 3 as a coefficient up in front of the CO2 on the product side. And then down here, we're going to change that 1 to a 3, right? Now, the thing is that 3 doesn't just affect that carbon, it also affects the oxygen. So we're going to have to, next thing we're going to have to do is change that. So we're going to take 3 times 2. That means that there's going to be 6. And don't forget that oxygen there. So the total number of oxygens now are 7. Okay, so now our carbons are equal. So we're going to move on to hydrogen. We had 8 on this side, and we had 2 on this side. Okay, so by the common numerator, we wouldn't multiply it by 8 because that would give us 16 over here. Instead, we're going to multiply, our common numerator would be 4. So if we multiply this 2 by a 4, we would end up with 8. Okay, so you're going to put a 4 as a coefficient up here, right, up in the reaction. Okay, so that changes our hydrogen. This one we didn't touch, this one we did. All right, and now it's also going to affect the oxygen behind it, right? So we're going to have, let's see, before we change the slide, what would it be? So now we're going to have 4 oxygen, because 4 times O is 4. And then here, remember, we had 6. So now we're going to have 10 oxygen. Yep, we have 10 oxygen, right? Remember, so we got that 4, and then the 6 is 10. All right, so looking at this, our 3s are equal, our 8s are equal. So now we're just concentrating on the oxygen. Right, and we have 10 oxygen here on the product side and only 2 here. So we need to multiply this side where the oxygen is by a 5, right, to get the 10. So we're going to put a 5 up here in front of that O2, right? And then once we carry out the math, we'll have 10 oxygens here and we have 10 oxygens here. So now they're all equal, right? So the equation, we know it's balanced when the number of each type of atom is equal on the reactant side and on the product side, when they're both equal. Okay, so this is going to be practice. So here we have mercury and oxygen, or let's see, mercury oxide reacts to form mercury and oxygen. All right, so here's where this comes into. See, a lot of students might think that G, well, what's the G element? Just remember, each element starts with at least one capital letter, and some have a lowercase letter, right? But there's only 2 atoms involved here. There's just mercury and oxygen, right? So what the first step that we would do is we would write these down alphabetically, right? So Hg comes first, right? Hg comes first, and then oxygen. And then the second step, we're going to write down the numbers per element. So there's 1 mercury atom and there's 1 oxygen atom on the reactant side. On the product side, there's just 1 mercury and there's 2 oxygen atoms. Okay. The third thing that we're going to do, we're going to make sure they're all equal. Okay, so the mercury is already equal. We're going to try to ignore the mercury. All right, so we're on the oxygen. There's 1 oxygen here and there's 2 here. So obviously, we can just multiply that by 2. We'll put a 2 up here as a coefficient. All right, we're going to put a 2 up here as a coefficient. All right, and that will change our oxygen to 2. All right, so now our oxygens are equal, but when we put that 2 up here, because the mercury was bonded to the oxygen, it changed our oxygen level. Okay, so what we can do, it changed our mercury level, rather. So what we can do is simply go over here and put a 2 up here. And put a 2 up here. Let me see what happens. Why is that not doing that? Okay, sorry, so I'm missing a slide. But you would put a 2 up here. And when you did, that would change to a 2. So you'd have 2, 2, 2, 2. And then it would be balanced, okay? All right. Last thing, if there is an odd number of any of the atoms, so when you're doing this, like say here, you've got 3 hydrogen and 2 hydrogen over here. All right, well, there's not, 3 doesn't go into 2 and 2 doesn't go into 3, so you can't just multiply 2 by something to get a 3. We don't want to deal with fractions and stuff. All right, so what you can do is multiply them by each other. So you have 6 as a common denominator or numerator. All right, so what you would do here is you would multiply this side where you have 3 by 2. And so you'd put a 6 as a coefficient up here. All right, but oh, okay, that's because there's a 3 there. All right, you would multiply by the 2, and that would change that coefficient to 6. All right, on this side, there wasn't anything up here in front of the H before. See, it was just blank, but there was 2 hydrogen. All right, so you would put a 3 as a coefficient, and you would end up with 6 total hydrogens on this side. Right? So that's what you do. Just like when we were writing the formulas for the compounds and stuff, and sometimes you would just multiply, for the crisscross, the 2 by the 3 by the 2. All right, as you get more practice on this, it really isn't that difficult if you follow those steps. Okay, so anyway, okay, we've already done this. Okay, so we did, right, okay, so remember what the equation was. This was the initial equation. Okay, we changed that to 6, and we put a 3 here. So now we've got our hydrogens are equal. But when we put the 3 here, that affected the oxygen. Okay, so we'll have 3 oxygens. So that tells us we have to come back here and put a 3 here, right? We've got a 3 oxygens now. We're going to put a 3 right here. Okay, and now it is balanced. So this is always your check. And so a lot of students might just want to plug in numbers in here and then count the atoms. But why doing it this way, why it's so effective, once you get that in the habit, once you get more practice and you get in the habit of doing this, this becomes your check, and it just becomes easier to sit there. If you just plug in numbers, yeah, you can look out, especially if it's an easy one, and get the right answers. But it could also take you a really long time, or you may not even, you may think you have it correct, but you don't really, they're not really equal. They don't end up really equal. You make more mistakes. This cuts down mistake, makes it easy. It's easy steps, and cuts down on you, reduces your chances of making a mistake. Okay, so that's how we balance equations. Hopefully that helps.